Hello, Pradeep. I am audible.
Yes, sir, you are good.
Okay, I will start within 5 minutes. Just wait.
Right.
Okay. Oh, anyone please? Uh, Hello, anyone please? Please mute your audio. Pradeep, we will wait another 2 3 minutes because I am facing some network problem.
No problem, no problem.
Currently, I have joined with my mobile, so please just wait.
Yeah,
Okay.
no problem.
Hello, Pradeep, I am audible. Hello, hello, Pradeep.
Hello.
Okay, I think voice is lagging, Pradeep.
I'm able to hear you, sir.
Okay, okay. I think I have some network problem today, or maybe some system problem. I don't know.
No problem, sir.
Yeah.
You can postpone, sir, if you like. Tomorrow also we can.
Your question was about week number 12, right?
Yeah,
Week number
I
12,
understand, sir.
your
Yeah.
question was.
So I think, sir, I feel that I think the answers are not correctly given by NPTL.
No, no, I have seen the answer was correct. There is no
That's,
issue, but
that's
we'll discuss.
maybe I'm wrong. Yeah. Yeah.
Okay, we'll discuss. Or you are telling the week number 9
The,
and 10.
no, sir, yeah, and as far as the links given, sir, it is leading to a general page, not
Yes.
not the solution page.
Okay, solution is not visible in the link,
No,
right?
no, sir, no, no.
Okay, I will inform. No problem.
Yep. Even if
Okay, your
sediment transport,
question.
sir. Yeah, yeah, sure.
Okay, you have question or not?
Yes, sir. Number 12, sir. Of course, if they give us the solutions, then no problem, sir.
Okay, I have also the question. Let me read the first question. The problem one. First problem was your question number 2, right?
Sir.
Okay, just wait. Question number 2 of the week 12, right?
Yes, sir. Yes, yes, sir.
The manufacturer of a car, right?
Yeah, yeah.
Okay, this question was about the mac. The question was about the manufacturer of a car reduce the drag coefficient of a car from 0.38 to 0.33.
That's
Okay.
true.
Firstly, drag coefficient was initially the drag coefficient was 0.38, but the manufacturer want to reduce it 0.33. Why he was to reduce? Because of, already, the as the drag coefficient will reduce, uh, your drag force bit reduce. So that's why. Okay, and he was to modify some design or shape. If on an average aerodynamic drag account of 20% of the fuel consumption. Okay, you are getting this question. What is written? If on average the aerodynamic drag accounts for 20% of the fuel consumption, the percentage reduction in the fuel consumption of the car due to reducing the drag coefficient. Okay, so here there is, you just focus on the, actually your fuel consumption is directly proportional to the your percentage of reduction in the drag, right? Hello, Pradeep, are
Yeah,
you
yes, yes.
okay?
Yeah.
So if you will somehow calculate the percentage reduction in your drag coefficient, then you can easily calculate the, that is your directly proportional. So if you will calculate, it will comes, I think, 1.58. I think it's okay. There is no issue.
I get 2.6 actually,
Yes,
like 0.05,
the
38.3.
percentage reduction in the fuel consumption of the car due to reducing the drag coefficient. Okay, in the question is given the 20% whatever the line is given if on average the aerodynamic drag accounts for 20% of the fuel consumption. Okay, the meaning is this your for like the 100% or if drag force is like that your 0.38, so in that drag force your fuel consumption it's relate with that, that is the 20% of the fuel consumption like that, right?
Yes, sir. Yeah, yeah.
But if you want to calculate the percentage reduction in the fuel, so if you calculate the percentage reduction in the drag coefficient and you will multiply that your 20%, then you can calculate easily. Like if you will calculate like 0.38 minus 0.33 divided by 0.38 into your 20%, that like 0.2, so you will get I think
So that becomes
0.38.
0.05.
Let me write on
Yeah,
the
yeah. Right, sir. Yeah. Yeah.
let me write on
Yeah.
this. So we'll discuss today about the drag and lift coefficient,
Right, sir.
drag and lift.
Right, sir.
So let me explain on the like that. Okay, your question is that the initial, it is visible.
Yes, sir. Yeah, visible.
It is visible.
Yes, sir.
Initial CD was 0.38. I think here I am facing some problem. And your it will reduce 0.33 and the fuel consumption on that was like 20%, right?
Yes, sir.
So reduction is how much? Reduction is 0.38 minus 0.33 with respect to, if you want to calculate the percentage with respect to previous one, that is the first one.
Sir. Sir.
So 0.38 into 100. So this is the reduction. Then how much reduction in your fuel? Into 1 point into 0.2, right?
Yeah.
So you will get I think 1.58. So this is the idea.
No, sir. No, not coming, sir. It's coming 2.6 actually.
How much?
2.6.
It
You
is
can do it,
coming
sir.
2.6.
Yeah, you can do it, sir. 0.05 divided by 0.38 into 100 comes around 0.2 to 2.6 something.
Okay, let me calculate.
Yeah.
0.38 minus 0.33 divided by 0.38 to Yeah, it is a 0.26%,
Yeah,
right?
yeah, yes, sir. Yeah,
So option D is correct for this, I think.
yes, sir. Because I saw the chat GPT also, sir. They also say the option D. Yeah,
2.6, right?
yeah,
So this is the correct one. So option number D is correct for question number 2, right?
right, sir. I feel, sir. Yeah.
Okay, okay. Okay, no problem. Or which question? Another
Uh,
question?
Sir, this is just a minute. I'll tell you, sir.
Question number
Sir, it is number four, sir.
4. Where is the problem in 4?
So water flows in the rectangular open channel with width 5 meter at a rate of 7.5 meter square meter cube per
So
second.
what is the critical depth, right?
Yeah, critical depth, sir. Because
So the
yeah,
formula of critical depth is what? If
so it is EC is equal to y plus v square by 2g or something.
yes, v square by 2g
Oh, sir. Yeah,
power 1 by 3, right?
right, sir.
So if you will
Uh,
calculate discharge is equal to area into velocity, right?
yes, sir. Yes.
So it will come like that, right?
Yeah.
So q by a square divided by 2z power 1 by 3, right? In the
Yeah.
question was given 0 point, let 7.5, and area is how much?
Uh, that is not given, sir. Okay. Well, height is given. Width is given. Yeah.
Area is not given.
No, sir. Only width is given. Base is given, sir.
Okay, so B is given. If you will calculate the your, if B is given, then you can take, I think square you can, if you will take, let me calculate like that.
So,
Your discharge is given 7.5 meters, right?
yes, sir.
Square, and 2 into 9.81, or we can consider the your B square, like we have like 25, right?
Yes, sir.
If B area is equal to, if we taken the B square, then what will happen? It will give the answer.
But y is, yeah.
Yeah, answer. Maybe here is written the rectangular open channel. So this is, I think,
But y become too big, sir.
7.5 square, 2 into 9.81 into 25, right?
So 25 is too large, probably too long for the depth, sir. Acha, acha, right. Okay.
Okay, I think, no, no, no. You know this thing, Q is
So,
equal to what?
so y1, y2, there is a formula, sir.
B by, I think you know these things, no?
The q by base, sir. Yeah.
Q by B.
Yeah.
So if you will calculate from here Q, how much you will get?
So 7.5 divided by 5.
7.5 divided by 5.
5.
How much? I think
So,
some question formation is 7.5 divided by 5 is equal to how much? 1.5, right?
1.5. 1.5.
You will get 1.5. If from here, if that
There is
is
some
your
y is equal to q square by
B
2g.
into
Yeah.
Y, so this formula become Q square, then B square 2G, right?
So,
So this is the formula. right? This is okay.
Yes, sir. Sir, but that Q square is bigger Q square, capital Q square.
Here y square, right?
Sir, that YC, that is, sir, you're telling Q square by GB square. Yes, sir. That YC is equal to Q square,
This is
capital Q
y.
square.
This is y.
Uh, uh,
Okay, just wait. Let me go in the proper way.
sir.
Okay, yc is equal to, we know the v square by 2z or g.
2G, sir. No, no, no. That is, sir, actually YC is equal to B square by uh, that is a Q square by GB square to the power root 3. Q square.
Right.
Capital Q, sir. Capital Q. Capital Q square.
Okay, let me check first. Just
Yeah.
wait.
By G B square. B is width.
Q square by z, right?
Yeah,
The
yeah.
formula is this. Okay, formula is correct.
No, sir. It is capital Q, sir. Capital Q.
Not a small q. If you will,
Small q is not, yeah, that root of this. Yes, you're right.
okay, a small q is given,
Yeah.
and a small q is equal to, you know already, that is the capital Q by B,
B.
right?
So
So in the
1.5.
in question, what is given? Now
Uh,
we
so
follow the
YC.
question
You were
things.
asking YC, sir. Only YC.
Your question is given Q, that is 7.5.
5.
B is given 5.
Yes. Yeah.
You will get 1.5. You
Yeah.
got the key Q, right? So
Yes.
1.5 square divided by 9.81
Yeah.
whole to the power 1 by 3. How much you will get?
So
Let me calculate.
so
1.5 square 9.81 power 1 by 3. 0.61.
yeah. But the answer is given is like 0.54.
0.54.
Yeah.
Okay, question number 4 and question number.
2, sir.
Okay, question number 2. Okay, now on another question you.
7, 9, sir. That is a 4-meter wide rectangular channel
Okay, okay.
conveys 15 cubic of water depth of.
A 4-meter wide rectangular channel convey 15 cubic of water at a depth 2.5 meter. Calculate the critical depth of the flow.
Sir, is there a difference between critical depth and specific energy and critical energy, sir? It is asking critical energy, but we know about critical energy, critical uh, energy, critical specific energy. We know, sir.
Okay, I think you are asking what? Please ask again.
Sir, it is asking critical energy. Uh, yes, ma'am. So it is asking critical energy, sir. But is there any difference between critical energy and specific energy?
No, where is the critical energy in this question? It is asking the critical depth.
Calculate the critical energy of the flow.
Critical energy your for rectangular channel, if you will ask 3 by 2 into yc. This is the critical energy formula, right?
Yeah, just we'll add EC only, sir. That's it.
Yes, critical energy. This is formula. So in this question, I think here is also a mistake.
I think, sir. I'll just check, sir. Just a minute for me.
Okay, let me check. So again, small q is equal to 7.5, that is your 15 by depth is how much? 2.5, right?
Yeah.
So how much you will get? 15 divided by 2.5. You will get 6, right?
Yep.
Maybe I think 6. Okay. And your g is given. So yc, when you will calculate, your 6 square divided by 9.81 power 1 by 3. You will get how much? 6 square divided by 9.81 power 0.33. So here 1.54, right?
Sir.
So this is also mistake. Question number 9, right?
Yes, sir.
Okay.
I think it should be 2.77. Some 2.71 something. Yes.
Huh?
It should be probably 2.77, sir. D instead of C.
No,
I,
no, 2.77 not. In this, I think 1.54 is coming.
oh, 1.54.
We need to change this. No, no, I think here depth was 4 meter. Okay,
No, the depth is
Pradeep?
2.5 meters, sir.
No, 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 no. Depth is 2.5 meter, but here we have done mistake. 4, I think, right? Your
Yeah.
Q is equal to watch capital
Q by
Q
B.
divided by B.
Yes, sir.
In this question, B is given 4, I think,
Uh,
right?
the yes, sir.
4 given, then you will get how much?
15 divided by 4.
Yes, 15 divided by 4, you will get 3.75, right?
Yeah.
3.75. 3.75 square divided by 9.81 power 1 by 3. So I think this is correct. This question is correct.
So that is WASI, sir. That is WASI is not a critical depth, sir. Not critical energy. It is asking energy, sir. It is
No, no,
asking.
in this question, question number 9 you are talking.
Yes. Yes, sir.
Question number 9, what is written? Calculate the critical depth or energy.
Energy, sir.
Okay. Oh, I was thinking it was, let me, question number 9, it is asking energy.
Yes, sir. So that is EC is equal to YC plus square by 2G. So if you got the YC is this plus the square by 2G, you have to do it.
If asking about energy, then formula is different.
So
Then formula is this thing. Okay. So 3.75 is 3.75 square divided by 9.81 whole power 0.33. If it is asking the critical depth, then correct, right?
yes, sir, yes.
If
But
it is asking 1
energy, sir.
point,
Yeah.
answer is coming 1.13. The option number, which one option correct? Option A or B, which option correct in the
Sir, I
question
think
number?
D is correct. D is
Huh?
correct, sir. I think so.
Which one?
D, sir. D. D for Denver. Yeah. D. D for Delhi.
Okay, 1 point into 1.5.
Yes, C is the answer given, sir, by the NPTEL.
Okay, if it is asking the critical depth, okay, I will check the problem. No problem.
So,
Okay, then again, your next question.
just a minute, sir. 9. So this 12, sir.
Question, you just read the question.
12. 12. So 12, a water discharge into a rectangular horizontal channel from a sluice gate.
Okay, 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 I am getting. So B is equal to how much given? Your width is equal to 25, right?
Yes, sir.
And velocity before jump, that is your 9 meter per second. That is your V1 given, and Y1 is given how much? Y1 is given 2 meter, right?
Sir.
Let me take the another. Y1 is given your 2 meter. B is given your 25 meter, and V1 is given your 9 meter per second. The flow depth after the jump, that is Y2 is right.
Yes.
So formula is Y2 is how? Y1 by 2. I think this formula you know already.
No, when yes. Yeah,
Plus
yeah, right.
square root, I think, right?
1 plus 8 F square.
1 plus
F,
8
F
F R1 square, right?
square. Yes, sir.
So how much you will get? Y1 if you will put
So it is
here
point,
2 by 2
it is point 0.5, sir. Yeah, point 0.5.
minus 1 plus 1 plus 8 FR1 how much? 9 by root G 9.812. 9 divided by root under 9.81 into 2. So 2.03. 2.03. So now we'll calculate these things. Minus 1 plus root under 1 plus 8 into 2.03. It will come 3.15.
Yes.
How much you are getting?
So I'm getting 4.83, sir.
Yes,
4.83.
you are getting 4.83.
Yes, sir.
How 4.83? Okay, okay, it will square. Okay. The fraud number is square. Yeah, 4.83, right?
Yes, sir.
So option D is correct for this. Okay, question number. This question number is 12.
12, 12, sir. Yes.
Okay, I will
There is a
examine.
last question, sir. There is another question, number 15.
Which one question?
Last one, sir. Calculate the terminal velocity of a 1 millimeter diameter raindrop falling in the still air. Last one, sir. Last one.
Yes, yes.
A dragon lift. I think it's the
Calculate the terminal velocity of 1 mm diameter raindrop falling in still air at a standard atmospheric pressure and temperature 20 degree. The drag coefficient is given. CD is given 0.672. Density of water rho is given 998 kg per meter cube. Density of air 1.2 kg per meter cube, right?
So,
And terminal velocity you need to calculate, and diameter of the raindrop 1 mm. So the option correct, which option is correct for this?
I think sir, A is correct, sir. But I think it is given 4.02. B is correct, they say.
Okay, if we calculate your VT, the formula is what?
Uh, terminal velocity, there is a formula, sir, for this.
I think 4 by 3 CD
What is it?
D V into rho water by rho air minus 1 and whole power 1 by 2. This is the formula, I think.
So,
Right. So if you will put all data, you will get, I think. Let me check.
good.
4 into 9.81 into 0.001 divided by 3 into CD is how much? 0.672 into 998 divided by 1.2 minus 1 to the whole power 0.5. So I think it is correct, 0.02.
Yes, sir, 0.0. No, sir,
Oh,
2.0.
4.02, yes.
No, sir, actually, there is a parallel velocity. There is another formula, sir. That root of 2 mg divided by CD rho A. Uh,
What is the formula you just tell?
uh, 2 mg divided by CD rho A. That
2.
root whole root, sir, whole root of 2 mg divided by CD rho A.
No, I think in this case, the formula of, the concept of the terminal velocity. Uh, this formula will,
Acha, this is better formula.
yes, if
Can you
let's
write down
suppose
for me?
one drop is falling in the air, what will happen? Your drag force will be act, right?
Yes, sir.
Your buoyant force will be act, FB, F drag, and your weight of the body also in the downward direction is falling, right?
So,
So terminal velocity is that when your force, that is your drag force FD, right,
so,
and FB will equal to your weight of the body, weight of the, or let's suppose particle or drop, whatever. Okay,
yeah.
so from here this formula is, if you will calculate, then you will get this formula, that like for your in this case raindrop, so water, and your FB is air, right?
So,
And the volume of raindrop is what? Gamma is equal to what? Weight by volume, right? So if you want to calculate, so here volume term will come. FB, I have taken FB this side, right? And FD is remaining here. So what is the formula of FD? Your CD into half rho AV square, right?
so,
So CD is equal to half rho A V square. If you will calculate here, volume is equal to what?
So 10 to the
Here,
power
volume
minus.
is equal to area into diameter of.
Yeah, it is 1
So
millimeter, sir. You have to convert into meter.
half into rho A V square. So your area is cancelled. What is remaining? That is here. What is remaining? So remaining I want to write here CD into half. So from here this formula is calculated, right?
So,
And V square is equal to gamma W, gamma your
here.
air into diameter of this. If you will convert in this rho, what will happen? Rho of water, rho of air into G
So,
D, right?
yeah.
So if, and these things, let me write here very clearly. So V square I want to keep this side. So V square is here. And what is remaining? Rho of water minus rho of air into G into D divided by your CD into rho of air, or your 2 will come here, right?
So,
So if by this rho W minus rho air minus 1, right?
yeah.
This rho air divided by this, right? So GD and CD. So this is the formula. The actual formula is this.
Okay, sir. P is equal to.
So we will use this formula for the calculation of a terminal velocity. Actual derivation is this, like this.
So,
So I think we have done somewhere. Actually, we have done somewhere mistake. You know where?
where, sir?
Actually, here volume is equal to, this is not like that. Let me write
Let
it.
us, let us do a clean paper, sir.
Yes, yes. Actually, your volume of what I was written, if drop is falling
Sir,
in
is 1
this,
millimeter, sir. You have to convert it to meter also.
you got the mistake?
No, no, no. We have to convert into meter, sir. That volume. It
Yeah,
is
yeah.
in,
This is not problem. What I am telling, the in the derivation, where is the problem in the derivation?
no, no. See,
And this is the buoyant force, and this is your FB, and this is your drag drag force, and this one is your body, that is the weight.
sir.
So weight of the drop is how much? Weight of the drop is rho G, rho of water, G into volume. Volume of a sphere is how much? Pi by 4, not pi by 4,
Uh, 3.
3 by
3
4,
by 4, sir. 3 by 4 pi r square cube or square cube.
pi r cube, right?
Yeah.
So this is the formula. This is your weight.
Yes, sir.
And your buoyant force, FB is equal to how much?
It is given, I think, sir. No, no.
You know the
Uh,
definition of FB, the
yeah, yeah.
volume displaced by. That is the same volume in the FB we will use, right?
Right, sir.
But here the rho of air G, and the same volume. 3 by
Okay.
4 pi r cube,
So
right?
yes, sir.
And your drag force Fd is equal to what? Half, that is your CD, drag coefficient CD, half rho A V square. So here area is what?
Yeah, pi r square,
CD
sir.
pi by, that is you half rho, and area is what?
R square, pi r square, sir. Pi into r square.
No, area is your, let's one raindrop is falling, then drag force acting on the circumference, right?
Yeah, 2 pi r.
Yes, pi d, or you can say the pi d, right?
Yeah, pi d.
Pi d or
But
2
sir,
pi r,
generally,
you
sir,
can
yeah,
also
yeah.
say,
Okay.
or v square.
But sir, area means we have to area, na, sir. The perimeter we are taking. Uh, okay, I don't know. Yes, yeah.
No, 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 no. You are telling correct. So let me write again. CD into half into rho. Area. Area is how much?
So pi r square.
Yes, or you can say these things.
Yeah. So above, so we're using three, sir. R, you are using R above.
Okay, we will finally convert in the D because of the your diameter is
So,
given
so
and V square is given. I think here if you are taking your full body, and when the your drag force will act, whether it will act on the full body or the half body, this is the another, you are getting what I am telling?
yeah, yeah. So I think sir, the full body seems like that, sir, because
Okay,
they are not mentioning anything half.
okay. Oh, let me check, no problem.
So,
So it is okay. Now if we equate these things, what will happen? If we equate the forces, all forces, your weight equal to Fb
FB.
minus plus Fd, right?
So, yeah.
So I want to write Fb, I want to put it in this side. So rho W minus rho air into G into 3 by 4 pi r cube, right?
Yeah.
This is good. Now F, this is FD. FD is
Uh,
equal to your CD into half rho pi by 4, or we can put in the, you are telling pi r square, right? Pi
so
r
in
square.
the LHS, sir, we have to write row W by row here, sir. But we have written row here only above. Row here.
Here, rho here. This is rho here.
The left side, sir. LHS.
This is rho here,
Row W divided by row here, you have written, sir.
not divided by.
No, 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 minus.
Yes, minus,
So,
and the v square. If you will equate, then your v, this is a terminal velocity. So pi, pi cancel, r square, only one r is remaining here, right?
sir. Yeah.
And these two will come here. So 2r is equal to means diameter, rho water minus rho air into G 3 by 4, and these two come this side. So 2r, that is your D, right?
Yes, sir. Yeah.
Here CD, I think you are getting or not?
Yeah, I'll get later on, sir. I'll just I'll do it later on. I see it here. Yeah.
Okay, and no, no, here it is not a big thing. Your weight, this formula you are getting,
Well, I never saw this actually,
you
sir.
know this thing, that is a unit weight is equal to weight by volume.
Yes, yes, yes.
This
Yeah.
definition you know.
Yeah, yeah, yeah.
And this is what? Your unit weight means your rho z. You know these things?
Yes, sir. Yeah.
So here only I have written these things.
Sir.
Rho z
Yeah.
and your volume. Your
Yes.
volume is equal to the volume of a sphere. Formula is 3 by 4 pi d
ID.
pi r
Yeah.
cube, right?
Yeah.
I think you are getting the weight part. Similarly, the buoyant force. In case of buoyant force, what we use the density of air.
Sir.
And the drag force formula is this CD half rho a v square.
Yeah. Yeah.
The A formula is pi r square, you know already.
Sir.
So only I have equated these things.
Yeah.
So now you will get this formula, I think. Vt is equal to, and everything you put downside. So rho omega, rho water divided by rho air minus 1 into G into 3 by 4 D or divided by CD. So these things we will apply in this equation. So finally what is coming? Finally your 3 by 4 CD into D into G into rho W minus rho air minus 1. So finally this is the equation. Your
Sir.
V is Vt square.
Yeah.
When you want to calculate Vt, then just you put power half and here square will be cancelled, right?
Yeah.
So I think this question is okay. There is no problem.
Sir. Uh,
But how much you are getting?
so just half, sir. 2 point something I'm getting, sir. 2.01. The answer given is 4.0.
The formula is 3 by 4 or 4 by 3?
3 by 4 by 3, sir.
4 by 3 I think, no?
Yes. Yes. Yes.
Yes, 4 by 3. So if here 4 by 3, your here also 4 by 3, 4 by 3, and here also 4 by 3, and here also 4 by 3. So if you will calculate like that, you will get the correct answer.
Okay. I'll try.
The final formula of the final formula is this one.
That's yeah.
Vt is equal to your 4 by 3 CD, right?
Yes.
Into D into G and rho water, rho air minus 1 or power 1 by 2. If you will calculate like that, you will get the correct
4 by 3. I think 3 by 3, 3 by 4.
answer. Right?
Yeah, I think it's 3 by 4, not 4 by 3. It's 3 by 4. Yeah.
Yes?
I think it's 3 by 4, not 4 by 3, I think, sir.
Okay, let me check. We have bit confusion regarding that. No problem. It's 4 by 3, no problem. 4 by 3 pi r cube, right?
Okay, sir.
Oh, it's okay. 4 by 3. So, okay, this is that. So, only the question number, I think, 4, 2, 9 or 12 question is wrong,
Sir,
right?
2, 4, 9, sir. 2, 4, and 9.
2, 4 and 9.
9 and 12. 12, 12, yeah. Uh,
The
12.
12 question was about your,
Water discharge into electrical
yes.
hydrogen, yeah.
Okay, we'll discuss about it. No problem. So now we'll start with the
Sir.
drag and lift concept.
Yeah.
So basically your drag and lift thing is very important in case of your designing the aerodynamic, that is aeroplane things, and your automobiles also. Drag and lift concept is very important. So basically your drag and lift means nothing, just this is the body is visible I think, and in the body your force is acting. When your body is, let's suppose here air is flowing or water is flowing, your force will act parallelly of the body, right? So
Yeah.
this is the shear, and and here one force will act normally on the body, and pressure on the body also act. I think this is visible arrow, right? So
Sir.
pressure is also acting on the body. So this parallel thing is your shear, and the perpendicular thing or the normal thing is pressure. So combining these things, one resultant force is come in the picture, right?
Yes, sir.
One resultant force come in the picture, combining these things. So if you will combine these things, then two force come in the picture. One is the lift force and another is the drag force, right? And these things depend on the orientation of the body, how your body orientation, like the angle of your body, how angle of attraction of the body, how the water or air act on your body. So this force will depend on that, whether the your lift force will be dominated or drag force will be dominated. So we'll see in the coming slides. So I think you are getting the what is drag force and the lift force, Pradeep.
So
Hello.
you're getting. Yeah, getting, sir.
Okay. So this is the drag formula of, if you will take drag coefficient, so we'll calculate like that, right? This formula will be utilized in the coming questions. So here you can see some friction of, or actually the lift lift thing is having the coefficient of lift, and that is lift coefficient, and the drag force is having the drag coefficient, right?
Yes, sir.
So drag coefficient not only depend on your friction of the body, it also depend on the pressure of the body. That is your drag coefficient is divided in two parts, your friction of the body, right?
Yes, sir.
And the pressure of the body. How much on the, that is the pressure is in the downstream side, right? This side. Let
Yes,
us
yes.
suppose this is your body, right? So this side pressure is how much, on that your drag coefficient pressure depend, and drag friction is depend on the your how much friction in the body. So this is the concept of the drag coefficient, that is the you're having the two parts due to the friction and due to the pressure, and the force similarly, your force, drag force having the two thing, your friction force, that is the, and your mm, drag due to pressure. So this is that. This is only the some here given the designing thing, how your, if the your vehicle is like that, then streamline how will we flow, how will vary, and if your vehicle is like that, how your streamline will appears. So if you see in this figure, here the very weak region is coming in the downstream of your vehicle, but this body, the shape is different. If you see the first shape and the second shape, the body shape is different. So actually what is done in this figure, we try to reduce your drag coefficient. Why? Because it's directly related your fuel consumption. If your drag coefficient is less, then definitely your fuel consumption will be less as compared to if the drag coefficient will be more. So this is the only graphical thing. And if you will see, this figure is what represent, if your if your let's suppose the air is acting on this what is the this shape. Let's suppose the ball. So if it will act on that, if you see, Pradeep, this is visible clearly or no?
Clearly visible, sir.
Yeah, if the force will apply on this upper part, then your drag coefficient is like that.
Right, sir.
If
Yeah.
your velocity acting in the lower, that is the your inner side, what will happen? Your drag coefficient will increase. So you just from this figure, you just some qualitative understanding may the drag coefficient may change by changing the body orientation. Are you getting?
Yeah, yes, sir.
If your velocity acting in the ball, what will happen? Your drag coefficient is increasing. So during the designing of automobile, these things we will considering very well. So I think this boundary layer concept I have explained earlier, but here also it is very very important. Let's suppose this is a plate is right. This is the plate and water is flowing uniformly in this direction, in the direction of flow. So in the first uh, in the first part, your laminar boundary layer, after that the transition region, and after that turbulent boundary layer. In the turbulent boundary layer, the boundary layer is divided in four part: the viscous sublayer, buffer layer, overlap layer, and the turbulent layer, right?
Yeah.
And from here, this is the critical. As your laminar boundary layer is that is the end, then at that location your critical boundary layer, or that is your critical section, we can consider. Why the critical things is important, critical location, you will see in the coming slides. Here also, how your drag coefficient, your friction coefficient is vary with turbulent boundary layer. If you will see, in the turbulent region, your drag coefficient, in the transition region, your drag coefficient is increasing, but as entering in the turbulent region, your drag coefficient is decreasing. So this is the,
I think the transition is the decreasing, right? Right, sir.
yeah, in the transition your drag coefficient is increasing.
Increasing, sir.
Yes, but as entering in the turbulent, your drag coefficient is decreasing
Decrease,
for
yes.
the same flow.
Yeah.
Now the question is very very important. Question is visible or no?
Yeah, visible, sir.
Okay, the lift force on a body is due to the buoyant force, is always in the direction of gravity, is the component of the resultant force in the vertical direction, is the component of resultant force in the direction normal to the relative velocity. So which one is correct?
So relative velocity.
No, no, relative velocity is not. In the first slide, I have tell you, it is the, where is, it is the
Resultant. So
component of resultant, right?
yeah.
In the normal direction. So the option number, vertical direction or normal direction, it is the component of resultant force in the vertical direction. What was, like a body is there, right? In the
Yes.
body, your shear force is acting and the pressure is also acting. Due to the pressure and the shear force, one resultant force is coming, right? One resultant force is come in the picture, and the component of resultant force is, one is the lift and one is the drag. In the vertical direction is lift force. Okay. Now the second one, a streamline body with a round nose and tapering back is generally best suited for, this is the only theoretical question, the turbulent subsonic flow. The answer of this type of say body, this type of say body is suitable for turbulent subsonic flow. Now this is also important question. The pressure drag result due to pressure drag, I have tell you now, before the your drag coefficient divide in two parts, one due to the friction and another due to the pressure, right? So where is the friction? Let's suppose this is your body. So the friction on the surface and the pressure drag in the down flowing, air flowing in this direction or water flowing in this direction. So your pressure drag is here. Your pressure drag is here and your drag coefficient due to the friction on the surface, this side also. So the question is that the pressure drag result due to formation of wake, turbulence in wake, and the existing of a stagnant point in the front of the body and the high Reynolds number. So one thing is very important. If you, let's suppose one body is there and water is flowing in this direction, or you can say air also is flowing in this direction, here one low pressure zone is existing. So this zone is known as the wake. So your pressure drag result due to what? Formation of wake. Right. You are getting, Pradeep?
Yes, sir.
Okay. Now
So
the question number.
A,
This
A,
is very
A
very
is the answer.
important.
The A is
I
the answer, sir. A is the answer. A. Digital. Formation of wake.
Formation of solid formation of a solid sphere, for a solid or a sphere falling under gravity at a terminal velocity of, in a fluid, right? So in the terminal velocity condition is what? The weight of your fluid should
Buoyant
be
force.
equal to buoyant force plus drag force,
Right. C, sir. Yeah.
right? This is the case of the terminal velocity and of the volume of what? 4 by 3 pi r cube, and area we will take pi r square in this case, right? In the
Sir.
drag coefficient we will use the area is what? Pi by r square, and in the weight we will use the volume part, that is your 4 by 3 pi r cube, right?
Yes,
So
sir.
option number which? Option number C is correct,
C is
boys.
correct, sir. Yeah.
Now the optimum efficiency of a falling, where is the question? The optimum efficiency of a lifting vane is limited by what? Actually, the
C,
optimum
sir. More
efficiency we
rapid.
will calculate on the basis of your
C.
CD and CL, right?
Yeah, yeah, yeah.
So option C is correct for
C is
this.
correct, sir. Yes.
A very teeny sphere, a very tiny sphere is settling down in a viscous liquid at a Reynolds number 0.2. Its drag coefficient is what?
Oh,
In this question, what is given? Your Reynolds number is given 0.2, right? That is a less than 1. So drag coefficient asking. You know the formula of drag coefficient? Please just write your answer. Just tell your answer. What is your? Another student join or not? Prashant, hello.
He is there, sir.
Prashant, uh, I'm audible, Prashant.
Yes, sir.
Okay, are you getting what I was telling?
Uh, Not, sir. Actually, I was thinking of other question which you were telling about the drag and lift for the water flowing on the flat plate. Actually, I was I am having some doubt on that, so I was thinking on that, sir.
Okay, you just ask. What is your
Sir,
doubt?
doubt is, sir, the sometime few time before you told that when the water is flowing on the flat plate, then there is a three zone is for always there. First is laminar, then transit, and third is turbulent. Agreed, sir. But
No,
sir,
not always, not always. I am not telling the always, but this three form will generally we can see. Yes.
Okay, sir. But my question is that the whenever the fluid is flowing on any surface, let here the flat plate, then the zone is created. But sir, that a particle which is in vicinity to of that plate will be the condition of no slip condition, and according to they will retard the particle flowing on that surface so in
Yes.
that way, the fluid particle gets retarded, and the velocity will be goes on increasing if we go on above. So question is my if the situation is like that, the whether the particle which comes into contact with that surface will remain as it is forever till the flow is there, or it will change its place as the time lapse.
Okay, okay, okay. Okay, I am getting your doubt. Okay, I will just explain. Before that, you just you have remember the formula of this question, question number six.
Sir, not sir. Actually, I was not.
Okay, okay, okay. Let me first tell the answer of this question. Actually, RE is depend on your what? 24 by not your CD is equal to, or you can say this type. So your CD is equal to 24 by RE when the your Reynolds number is less than 1, right?
Sir,
So 24 by RE is equal to 0.2, so you will get 120, right? So
sir,
option B is correct for this.
Yes, sir. Got it.
Now coming on the question number, before going on the question number 7, let me discuss what he was telling. Let us suppose a plate is there, that is the solid body, solid surface, and what will, and uniform flow here I have considered. So as the fluid particle contact this plate, what will happen? The velocity of the fluid particle will be zero.
sir,
And due to the what? Due to the no slip condition, you know already.
yes, sir,
So what will happen? The flow is flowing as a sheet flow, or you can say the layer by layer. For your understanding, I want to draw in the zoom view. The water is flowing like that, right? If
sir,
this particle is stop here, that is the velocity is zero, what will happen? This particle will try to reduce the velocity of this layer, velocity of this. If it is zero, then upper layer, that is the lower layer, try to reduce the velocity of this layer try to reduce the velocity of this layer. After some time, what will happen? The effect of wall in the y direction, that is this is y direction, in the effect of wall in the y direction will be negligible. So after that, there is no effect on the in the fluid flow, right? So this is
So
the concept. But you are the question was Prashant was asking after the time, let's suppose after this I was analyzing, that is the at let's
times.
suppose 8 a.m. So after 10 a.m. what will happen? After 10 a.m. will still remain same. There is no, if the velocity is your same and everything is same, then it will
Yes.
be the same condition. There is not effect on this velocity profile at a particular location if everything is same. I
Okay. Okay.
think
That
hope you
will.
are getting.
Yes, sir. Yes. Yes.
Okay, now we'll move on the next question. Okay, the critical Reynolds number at which there is a sudden drop in the CD value of the cylinder is about, this is the only the data. So this is option number C is correct for this, right? I have some graph for you. So this is the graph for a smooth cylinder. So around 0.5, after the 0, after 10 to the power 5, your drag coefficient value is falling, right? So this is only your, this is the experimental question, no. Okay, question number 8 is what telling, if the power of, if the power to overcome aerodynamic drag of the air remains same, what percentage increase in the velocity is reflected by 15% reduction in the drag coefficient? Oh, what is, Pradeep, are you getting this question?
It will be good that we please explain it. Yeah.
Actually, the question is asking what percentage increase in velocity is reflected by the 15% reduction in the drag coefficient.
Okay, sir. Yeah.
That is your previous one. Let's suppose your CD1 was about CD, right? But after reduction is what? Reflected by 15% reduction in the drag. That is your 0.85 CD,
Yes, sir.
CD2, right?
Yeah, yeah.
Now, what percentage increase in the velocity?
Velocity. Yeah. So
So your CD is related with how? FD divided by half rho AV square. This is the formula.
yes, sir.
Power is same.
Our is
Power means you know the power formula is your FD into velocity.
so stream power is same. The power, sir. Stream power is same. Is
Which
power.
one? If the
Stream power.
power to overcome the aerodynamic drag, yes, power is this. The drag force into velocity is remains same. That is your P1 in the P1 case and P2 case, right?
Yep.
This is the question is telling these things.
Yes, sir.
So if you will put everything, let let us put your half CD1, right? It is visible or not? Not visible. Let me take the another. Your question is telling the P1 is equal to P2, and this is FD1 into V is equal to FD2 or V1 V2 you can tell. So CD1 into half rho A V1 square into V1, right? CD2 half rho A V2 square into V2, right? So everything is constant. This is cancel and this is cancel. CD1 was about CD.
FD1, it should be FD1, is it not? V1 is the
Yes,
V1. Instead of V1, we can write FD1 uh, or FD1, FD into V1 is equal to FD2 into V2. So,
what you are telling?
no, CD into half rho AP square into V1. So,
Yes,
we need to, instead of V1, so we need to multiply the whole thing, FD into V1.
yes. We will multiply, we will get these things, right? V1 cube. And here this side V2 cube. Oh, this is here everything is in the multiplication. So
Okay.
no need the multiply, right?
Yeah. Chalo, ठीक
So,
है. Yeah.
so your CD is cancelled. The question is what? What percentage increase in the velocity, right? So your V1 divided by V2 is equal to what? By Q 0.85. So V1 by V2 is equal to 0.85 power 1 by 3. How much? So this type of question you can expect in the gate also. This type of analytical question, I think 0.85 power 0.33, 0.947, right?
Yeah.
So your V1 is equal to how much? 0.947 V2 and V2 is equal to. So percentage how we will calculate? Question is asking what percentage increase in the velocity. Increase means from the previous one.
Yeah.
So your V1 minus V2 divided by V2, or you can say not V2, from the previous one is V1, or this is the modulus, you know already. So if you will calculate how much you will get,
So 0.947 V2.
1 minus point 0.947, your V2 cancel. So I think 5.3% your will increase. Okay, so option number A is correct for this,
Yeah.
right?
Yeah.
Are you
5.57.
getting how you will calculate?
Can you explain again, sir, please?
Okay. In the question is given the previous term, if the power to overcome aerodynamic drag of an aircraft remains same, right? So what percentage increase in the velocity, right? How much your velocity will be increased if the your drag coefficient reduced by 15%, right? Drag coefficient reduced by 15% means what? Previously your drag coefficient was CD and 15% if you will reduce, then 0.85 CD will remaining, right? This thing you are getting.
Yes, sir. Yeah.
Okay. Now the power formula is force into velocity, right?
Yes.
Force into velocity. So your drag force into velocity. In the first one, V1, and in the second, V2. So the formula of drag force is what? CD half rho A V square. So V1 square, or V1 already here, so V1 cube, right?
Okay.
This year the 0.85 CD2 was what? 0.85 CD, and V2 square, and V2 is V2 cube.
Yeah.
So from here only calculation, V1 by V2 is equal to 0.85, 1 by 3. You will get these things. So V1 is equal to what? 0.978,
970. Yeah.
right? And V2 is equal to your V2 already, right? So if you will calculate the percentage increase means what? With respect to previous one,
Yeah.
right? So with respect to previous one, your V1 minus V2, or you can say the V2 minus V1. Always the modulus is here, right?
Right.
So how much your increase in the,
Yeah. 0.57.
okay. So this is the your, or here you can also say, here you can also see your V1 is equal to how much? That is the less than 1, right?
Yeah.
This term is what? Less than 1.
Yes. Less than
If
one.
you will see, so your V2 is increasing. From here you can also visualize. Are you visualizing or not? Are
Yes.
you
Yes.
able to
Yes. Yes.
visualize?
Yes. Yes.
Your V1 was what? 0.9 something, 0.947. 0.97, 0.947 of V2.
Yeah.
You
So
know
V2 is
already
more.
the 0.947 V2 is less than V2.
Less than
This is
V2.
correct or not?
Yes.
And this value is what? This value is V1. So V1 is less than V2. So as you're decreasing your drag coefficient, your velocity is increasing. So that's why in the question, the percentage increase in the velocity is how much? 5 point something. I think 5 or 3%. So I think this is very, very important. This is an analytical type question, and this type of question you will expect in your GATE exam. So this is the only, you can take the screenshot of this question just for your practice. Or we can solve here also. What is actually written? A 2.2 centimeter outer diameter pipe is to span across a river a 30-meter wide section. Here the figure is visible, right? While being completely immersed in water. Completely immersed in water, okay. The average flow velocity of the water is 4 meter per second, and the water temperature is 15 degrees Celsius. Determine the drag force exerted on the pipe by the river. So this is the practical, some pipe you have put in the river, then how much drag will act on the river, will act on the pipe. So how you will calculate? In the solution part, you just see a pipe is submerged in river first, and the drag force that act on the pipe is to be determined. This is the assumption is what? The outer surface of the pipe is smooth, can be used to determine the drag coefficient. We will use here the smooth type of pipe. Water flow in the river is steady. We have assumed the steady flow. The direction of water flow is normal to the pipe. That is the normal to the pipe. Are you getting the normal to the pipe meaning here?
Yes, sir.
The turbulence in river flow is not considered. These are the assumption. Based on this assumption, we are going to calculate, right? So what is given at 15 degrees Celsius? Your density is this, and dynamic viscosity 1.138 into 10 to the power minus 3, these things. And D is given how much? 0.022 meter. The Reynolds number you can calculate easily. Rho V D into your mu. So this is equal to 7.73 to the power 10 to the
4.
power 4. The drag coefficient corresponding to this value from figure, that figure I was I think 34. If you will take the figure here, 34 figure, so your CD corresponding to 7 point, that is a 10 to the power 4. If you will see here, 10 to the power 4 for a smooth cylinder. So this is almost come around the 1 this way. So that is why here CD is equal to 1. Also, the frontal area of flow past a cylinder is L into diameter. That is your length. How much length is there? And your diameter of the pipe. That is the frontal area. If you will see the pipe from the front, how it will look like? It will be look like that. So this is the frontal area, your length and the diameter. Now the drag force acting on the pipe, you know the formula already. So it will come like that, your 5300 Newton.
What is the role of RE, sir?
Where is
Role of RE, Reynolds number.
Reynolds number? Okay, we use the Reynolds number for calculating your drag coefficient, right?
Yes, sir.
From the figure number this. Reynolds number
Okay,
come
okay.
around your 10 to the power
I
4.
understand.
So for 10 to the power 4, your Reynolds number, your drag coefficient here, and the y-axis is what? Drag coefficient, and in the x-axis, your RE. For 10 to the power 4 RE, your drag coefficient coming around the, for a smooth cylinder is 1, right? So in this question we have taken.
Yeah, that's yeah.
Okay. So what is the discussion is written? Discussion is also very, very important. Note that this force is equivalent to the weight of a mass over 50 kg. Okay. This is equivalent to 50 kg. Are you getting how it is?
500, sir.
You know,
I,
na,
I,
force is
I
equal
100,
to sometimes. Okay.
500 kilogram.
Yes. So 500 kg. Therefore, the drag force the river exert on the pipe is equivalent to the hanging a total of over 50 kg in the mass of the pipe supported at the end of the 30-meter apart. Are you getting what is the discussion is? If the drag force acting on the pipe, this here is acting overall, is acting the 500, the 5300 Newton, that is your 500 kg. So it is equivalent to, just for discussion, equivalent to the 500 kgs hanging on this here, on this support and this side. So you need to design like that. So another
Very heavy,
thing,
sir. Very, very heavy. Yeah.
yes, the necessary, the precautions should be taken if the pipe pipe cannot support this force. So if the river were to flow at a faster speed, or if the turbulent fluctuation in the river were more significant, the drag force would be even larger. Unsteady force on the pipe might then be significant. So this type of conclusion you always, when you solve any question, so you always try to do this type of conclusion in your mind, or you can write also in the exam also. So this is also very important question. So based on similar, this is the similar question. Whatever the example is here, the similar is. So actually this is the last one. We'll just solve the effect of spin on the tennis ball. So what is written? A tennis ball with a mass 0.125 lbm and the diameter 2.52 inch is hit at 45 minute. What is written? The milli-inch.
Miles per hour, sir.
This is the mi
Miles.
miles per hour, right?
Miles.
Okay. Is hit at the 45 miles per hour with a back spin of this RPM, these things 4800 RPM. The figure is given here, and determine if the ball will fall or rise under the combined effect of gravity and lift due to spinning shortly after being hit in air at 1 atmospheric pressure, that is at 1 atmosphere and 80 degree Fahrenheit. So question you are getting, what is question is telling? Actually a tennis ball is given of some mass and the diameter of the tennis ball is this, and hit a, that is, and hit at, that is the velocity is something is given with a back spin or rotating, also ball is rotating also. So it is hitting something with the weight is given of the ball, diameter is given of the ball, and also ball is rotating, and the velocity, forward velocity is also given. So this, all these things is given in the, that is given by this. Well, uh, let's suppose you are throwing the ball uh, with the rotating. So determine if the ball will fall or rise under the combined effect of gravity and lift due to the spinning shortly after being hit in air at the pressure and temperature is given. So basically here you need to calculate the lift, and that is the lift thing. So a tennis ball is hit with a back spin, and it is to be determined whether the ball will fall or rise after being hit. So this is the your question. The assumption is what? The surface of the ball is smooth enough. This is the assumption. And the ball is hit horizontally so that it start its motion horizontally. The assumption is also one there. The ball is hit horizontally so that it start its motion horizontally. The properties is given, you know already. So we'll see only the how the concept for this question. The ball is hit horizontally and thus it would normally fall under the effect of gravity without the spin. The back spin generate a lift, okay, and the ball will rise if the lift is generated than the weight of the ball. So if lift is greater than the weight of the ball. So what is actually meaning, if somehow if lift force is your more is greater than the weight of the ball, then what will happen? Then it will be rise, otherwise it will be fall. The lift force will be determined like that. Your FL is equal to CL A rho V square by 2. So here is the only conversion things. Velocity is converted in feet second and your omega is converted in your radian per second. So here also these things. So now if you will calculate your FL is come, the formula is FL is what? FL is equal to CL into rho, that is a half V square. So only here data is putting. So your FL is come like that. The weight of the body is come like that. So what will happen? Which is more than the lift? Your weight is more than the lift. You have, if you are getting, hello?
Yes.
Yes, in this case, you actually the concept is very important for this question. The only the calculation you can do easily.
Yeah.
So here the weight of your body is greater than the lift force. So what will happen? Therefore, the ball will be dropped under the combined effect of gravity and lift due to spinning the. Okay. So the conclusion is what? This example shows that the ball can be hit much farther by giving a back spin. Note that the top spin is opposite effect. That is the top spin means, are you getting? The back spin is this side, and the top, like if you are going to top spin, this is the top side spin. This is the back spin, right? So if you will do the top spin, then effect will be the opposite definitely. And also the Reynolds number for this problem is 8 into 10 to the power 4, which is sufficiently close to the 6 to the 4 for the figure number 53 appeared. Okay. Also keep in mind that although some spin may increase the distance traveled by the ball, there is an optimal spin that is a function of launch angle, and most golfers are now more aware, and too much spin decrease distance by introducing the more induced drag. So basically it is just this line is correlating with the uh, practical approach of this problem, where we use this concept in the practical, that is the golfer mostly use. So the question number 9 is, we can solve the question number 9. The question number 10 is similar type of question. You just solve this. The question number 10 is visible. Pradeep.
Visible.
Okay, you can take the screenshot of the question number 10. Then we'll solve the question number 9. You just take. This is the similar question of question number 9. Now come on the question number 9. It is very, very important and easy. A flat plate of 2 meter long. A flat plate is given and the length is 2 meter. And wide is, let's suppose it is wide wide is 1.5 meter, and throw at 30 kilometer per hour in water. That is your velocity is given 30 kilometer per hour. So if you will calculate in meter per second, 30 divided by 3.6 meter per second. How much?
Uh,
30 divided by 3.6. 8.33.
8%.
8.33 meter per second. Right. So now the drag and the lift coefficient are given. The drag CD is given 0.2 and CL is given 0.6. Calculate the resultant force. If resultant you need to calculate, right? Are you getting? And the power,
Yeah.
FD into velocity. So these two things you need to calculate. So how will calculate? You know the formula of FD, half rho A V square CD. So half into 1000. Area is how much? 2 into 1.5. V square is, that is your 8.33. 8.33 square into CD 0.2. How much you will get? 1000. 2 into 1.5. 8.33 square into 0.2. You will get 20.816 kilonewton, right? Similarly, FL you will be get, only you need to change the coefficient one. That is your 62.45 kilonewton. How much you will get the resultant? You just root over and calculate. Root under 20.816 square plus 62.45 square. You will get the 65.82 kilonewton, right? And your power will be 20.816 into velocity is 8.33. You will get 28.816 into 8.33. So hope I think
40. But sir, it's not matching. It is not matching with the answer, sir.
yes.
It's not matching with the answer. And yeah, row.
Your resultant is not matching.
Yeah. Anyway, not a big deal, sir. Is the process? I know, we know. Yeah, something there may be some mistakes.
Okay, that is not 20. That is this is your 20.
20. Yeah.
So if we will, let me calculate 20.816 into 8.33, you will get 173.4. So option number A is correct for this.
Yes, sir. Yeah.
Hope I think you will get. So okay, today we'll finish this fluid mechanics NPTEL live TA session for this 2023 session, or the question number 4 to 9 and 12, right?
Yeah.
Okay, about this I will talk. Okay, then thank you, will, and best of luck for your exam, for your
Thank you,
final
sir.
exam.
Yeah, thank you, sir. Thank you so much.
Okay,
Yes. Yeah, thank you, sir.
okay, thank you.
Thank you, sir. Thank you so much for cooperating. You are a nice man.
Thank
You're a nice person, sir.
you. Okay.
Very friendly and like you answer every question also.
Yeah, okay.
Yeah.
Okay, Pradeep.
Okay, sir.
Hope.
Thank you, sir. Thanks.
Uh,
We'll meet again, sir.
okay,
Yeah. Thank you,
definitely.
sir.
If you have
Sure.
any doubt, you can mail me. You have already my email
Yes, I
ID,
have, sir. I have, sir. Yeah.
and I want to write mail ID here also. Last time. So I have written my mail ID in the chat box. If anyone having any type of doubt, please ask. Okay, Pradeep, thank you.
You wrote something, sir? Not visible.
Yes,
Wrote something, sir? You wrote something here? Did you write something, sir? Did you
yes,
write
yes.
something?
I have. It is
Oh,
visible.
right. Okay, okay, right. Yes, I got it.
Oh, I have written my mail ID here for
All right.
the,
Yes,
yeah,
yes.
for future.
Yeah, yeah.
If you have any type of question,
Sure.
you can definitely ask. Okay, thank you. We'll meet maybe in the next, if you want, in the coming NPTEL session. You want to take any subject?
Uh, I don't know, sir. Depending on which course is available.
Okay, okay, okay,
Yeah,
okay, okay,
yeah.
okay,
Thank you, sir. Thank you so
okay.
much.
Thank you. Bye bye.
Sure.
Good night.